Now, okay lads, so I'm going to look at the 2018 question 6. It's the ellipse question. And I'm going to work my way through it and talk about the different principles that we need to know in order to solve this question. Okay. Now, so just let me see. Is that too dark? Okay. Now, right. So in the question here, I have it up, and it says the figure shows a design for a high loading tool. The curve ABCD is a portion of an ellipse with a major axis AD. So there's A, B, C, and D. Okay. With a major axis of AD. So here's AD. Now, do we have the length of the major axis in this case? We do, because we know from the center point of the ellipse to D, we're told is 80 millimeters. So that means the length of the major axis, so the length of the line AD, has to be 80 by 2, which is 160 millimeters. Okay. Point B is a point on the curve. Okay, so here's point B, and we're told that it's over 66 millimeters from the center, and it's also up 24 millimeters high. So from that, they're asked us to determine the length of the minor axis and draw the ellipse. Okay. Now, so what I've basically done here is I've just drawn in everything that we're given in the question. Okay, so I'll just put it in a little bit heavier in case we can see. Okay. Now, so in the question, we're told that this is my center point. We're told that the major axis. Okay, I'll zoom that in a small bit. Okay, there we go. We're told that the major axis is 80 millimeters wide. Okay. Half the major axis is 80 millimeters, so the full major axis is 160. And we're also told that the point B is over 66 millimeters. Okay, and it's up 24, like I've done. Now, so from this we need to determine the length of the minor axis and construct the ellipse. Okay, so if I have my major axis here, that means I can go ahead and I can draw in my major circle. Like so. Okay, now, so from here we need to figure out how to find the length of the minor axis. Now in the question, all we have is the major axis and a point in the curve. I know from my point B, which is my point in the curve, and let this principle works for any point in the curve, no matter whereabouts in the ellipse it is. If I bring my line straight up from B, okay, to where it hits the major axis, I'm going to join that point back to the center point, and I'm going to draw a horizontal line across from B until it hits that line, like that. Okay, now I know the distance from the center point, point C, to this point here is going to give me the length of my minor axis, which is also going to be the length of my minor, or the radius of my minor circle. Okay, like this. Now, so I'll just go ahead and I'll draw in. That's going now. So this line here. So this is A. This is D. I'm going to call this line J and K. So the line JK is the length of my minor axis. Once I know our principle, from here then I'm going to go ahead and I can construct the rest of my ellipse. So it's going to be similar to before. We're going to bisect their circles up using 30-60 set square. And okay. So again, lads, this is the same principle as when we're drawing any ellipse. Okay, we're coming out from them. Now, so I know that both ends of the major axis are already 2 points of my ellipse, and both ends of the minor axis are already 2 points of my ellipse. So then I have one, B, I know B is the point in the curve. Okay, now all of these are going to be points on my elliptical curve. Now in the question we're told that only from A, B, C, D is a point curve in our ellipse. Okay, so I'm gonna just draw in this ellipse, but it's going to be in light construction lines for the start. Okay, so again everything's freehand. And whatever way you find it easy, if you find it easier to turn the page around, or if you want to stand up around your drawing when you're doing it, by all means do. Okay, and now we're going to have our ellipse drawn in. Okay, so that's the first part of the question complete. That's drawing the curve ABCD. Now we're told that the curve UV with a vertex at U is an identical portion of the same ellipse. Okay, so the first thing is identify where the curve UV is. So this is the curve here, UV. And we're told that it has a vertex at U. Now, so we're told from C up to U is 60 millimeters. So I can go ahead now and I can draw that in. Okay, so I'll put 60 millimeters. So and that's going to give me that point, which is point U. Okay. Now, so what are we told then? So we're told that with curve UV with vertex at U is an identical portion of the same ellipse. Okay, so the same ellipse we've drawn here, this curve here UV is going to be an identical portion of that ellipse. So we have to identify which part of the ellipse is the same. So if I was to take this curve, I could rotate it down into the bottom left hand corner, or I could put it into the top right hand kind of corner, and both these sections would be identical to that. So I'm identifying now that the point U is the same as the point D. Okay, now this makes sense in a second. This is 60 millimeters across, so what I'm going to do is I'm going to measure 60 millimeters across from D and get a point. And I'm going to take this width here. I'm going to divide this section up, and divide it up to 20 and divide it up into 40. Okay. From these 2 points then I'm going to get the width of my ellipse at them points. Okay, so I've identified this height, and this height. And I know point D is going to be my point U up here. So the exact same thing I'm going to divide up here into different widths. Okay, and I'll just draw. Okay, drawing 2 points out like that. From here, because I know this is identical ellipse, I'm going to take these sections of the ellipse here and I'm going to bring them down. So I'm going to call this one number 1, this one 2, and this will be 3. Okay, so this is point D is point U, this is going to be point 1, this is going to be line 2, and this is going to be line 3. Okay, I'm taking the width of 1. Okay, so that section there. Bring it up. I'm going to mark it off. I'm taking the width of section 2. Bringing it down. Marking it off. I'm going to take the width of section 3. Bring it down. Actually, don't have the line drawn in for that, so I'll just draw it in. Okay. And then I can, if I want, yes, that's fine. So now I've identified that this point, and point U, and I continue that on. So if I draw this section in, I'll call this point V here. So now I know that curve UV is an identical portion of the very same ellipse. Okay, we're told that the width coming out from that is 17, so I'll come out 17 millimeters. Because there's 15, 16, 17. And I'm going to that joins back up here like this. Okay, so there we go. Now, so just to so that's going across from point B, and we're told that there's a 45-degree line coming down like that. Okay, so that's going to get me all these heights here. Like that, so we're going to end up with something like that. Okay, maybe the curve will be a little smoother than that, but okay, so that's the second part of the question complete. Now, we're told that the line BT is a tangent to the ellipse at B. Okay, so the line BT is a tangent to the ellipse at B. So again, we're going to identify where point B is, and we've identified that it's here. Okay, so we took that from the start of our question. I want to draw a tangent to the point B, okay, that comes to, I want to draw a tangent to the ellipse that goes through the point B, okay. Now, if I'm drawing any tangent to an ellipse, what I need to do is I need to find what's known as the focal points of my ellipse. Now, I know that half the width of the major axis, okay, swung from either the top or bottom of the minor axis is going to give me the focal points. Okay, and I'm going to call these F1 and F2. Again, it doesn't make a difference of the, if I could have called this F1 and this F2, it's just the names I put on them. Okay, now if I want to draw a tangent to an ellipse from a point on the curve, again, this is we're focusing here with point B, but this is the same principle for any point on the curve. What I'm going to do is I'm going to try and join one focal point up to B and extend the line through it. I'm going from the second focal point and draw a line and I'll extend it through that. Now, I know that a tangent is a line that passes. I know a tangent is a line that touches the elliptical curve at one point only. Okay, so I'm left with two angles here now. If I was to bisect the angle F1B, okay, and this angle here, if I'm to bisect that angle, I'm going to get a bisecting line. It's only going to touch the ellipse at one point, which is going to be my tangent. However, if I was to bisect this line, okay, I'd be getting an angle that's at 90 degrees to my tangent, and that's going to be known as my normal. But in this case, I need to draw my tangent. Okay, so I'm going to bisect my angle. So again, set my compass. Now, so that bisecting line is going to be tangential to the ellipse at the point B. Okay, so now we've the line BT is a tangent. So now I just need to identify where the point T is. Okay, so what are we told? We're not given a distance out for T, but I know that it intersects this curve here, which is the curve KMN, which is a parabola with a vertex at M. Okay, so now what I need to do is I need to draw in this parabolic curve. Now, so we're told that M is the vertex. We're told that in this case the height of the ellipse, okay, because we're looking at the vertex, we're looking at the center line as a horizontal line, is 65, and the width is 75. So I need to draw on my box now 65 millimeters by 75 millimeters, and that's starting 49 millimeters from the center of this circle. Okay, so basically from the center point I'm going to have to come down okay, I'm going to have to come down. I'm going to have to come across 66 millimeters for a start, so let's start with there. Okay, so let me see the bottom. Okay, we want to try to find this bottom set corner of the parabola. So I know that if I come down 32 millimeters, that's going to get me the center of this circle or wheel, and then I know that outer diameter, or the diameter of that wheel, the radius rather of that wheel, is 27. So if I come down 32 plus 27, that's going to get me the bottom. So 27 37, 47, 57, 59 millimeters. So I need to come down 59 millimeters. Okay, there we go. I'm going to draw in my line. Now, okay, so I need to come across 66 plus 49. So my first one is 66. Mark that off. I need to come across now 49. I'm marking that off, and that's going to get me the start of the box. So now I need to come to 65. Guess we'll extend that line out. 65 millimeters. Okay, now I know the width of the box is 75, so I'm going to come up 75 millimeters and do the same from here. Okay, and then I'm going to join them lines there like that. Okay, now, so sorry we didn't see that. Just move that across. Okay, so now what I need to do is I need to draw a parabola in this. Okay, so I need to find the vertex M. So I know the vertex M is under 75, so I know it's halfway between these 2 points. Okay, now what I can do is I can measure half 75, or I can just, to make sure that I'm fully right, I can just bisect that line, which I'm going to do. Okay, so I'm going to bisect this line like that, and then that's going to give me my vertex M here. Okay, now okay, so this line here is going to be my center line of my ellipse. So what I need to do now, or my parabola, I need to find a series of points on this here now, in order to put in my elliptical or my parabolic curve. So I'm going to divide up my sides, okay, into a number of parts. Depending on the number of parts I divide them up into, is going to determine how many points I'm going to have on my parabola, and will determine how accurate it will be. Okay, so general rule of thumb, if we're drawing a full ellipse, okay, if I divide the bottom section into 8 parts, I'm going to divide the side into 4. Okay, if I divide this into 4, I'm going to divide this into 2. Okay, so I'm going to pick and I'm going to divide this bottom into 6 parts. So 1, 2, 3, 4, 5, and 6. Okay, now I want to divide this line into 6 equal parts, so I'm coming along and I'm getting my sliding set squares. So I'm joining the very last point to the end, to here, and I'm using my set squares going along to get a series of parallel lines. Okay. And the last one. Now, so now I have 1, 2, 3, 4, 5, 6 equal parts. Okay, I said if I divide this up into 6, I want to divide this one up into 3. Okay, so I'm going to go 1, 2, and 3. Similar to that, I'm going to use my sliding set squares. I'm going to have 1, 2, and 3. Okay. I also need to divide this line up into 3 parts, but because I have one side divided, I can just transfer my points over. Okay, so like that. Okay. So now this is my vertex line. The bottom line I divided up, I need to draw lines parallel to my vertex line. Okay, so from here I'm drawing lines up parallel to this. Okay, like this. Now the rest of these points have to come back to my vertex. So I'm joining this to my vertex. I'm joining here to my vertex. Now, so this is what I'm left with. Okay. Sorry. Then So now I know I can divide, once I join these up, so this first line here, I'm joining with the first, this first line, I'm dividing up with the first line that goes to here, the second one, bring the second one, this is the center point, so that's on my vertex. That's going to give me my parabolic curve. Now, we're told that this angle down here is at 75 degrees from this, so I'm going to measure up and I'm going to get my protractor and measure 75. Then I can draw in that line there, and that's going to get me that curve section. Okay, so we're told then that the line BT, okay, so where it intersects, so this is B, that's going to get me point T there now. Okay, what else from I do? Okay, so then I can draw in everything else, so that's going to be my line BT. Okay, now what next I need to do is I can draw in the wheel section of the two wheels of the loading truck. So I know the center point for these two wheels are coming down 32 millimeters. Okay, so we're going down 32, and I have that line already in. Then we're coming across 66 from each, so I'll come across 66. Let's get me that point and that point. Okay, I know my radius of my circles for my wheels is 27 and 12. 27 for the outer one and 12 for the inside one. So we'll go 27 first. There's 25, 6 and 7. Okay. And I'll draw in them. Go to say on the far side. And I know the inside wheels are 12 radius, so there's 12. Okay. So this is now what we're left. It's starting to take shape now. So we see that this line here is just a 10-degree line coming from the center point of the first wheel until it intersects the parabolic curve. So we're coming along, getting my protractor, measure up 10, and it's going to come like this, okay, until it hits my elliptical or my parabolic curve. So from that, it's just a matter of, from here, it's just a matter of joining up all my points, okay, getting in the rest of my lines. So I see that I have a line coming here, and so forth. Now, I drew a lot of this in heavy lines just so you can see it on the visualizer. So I'm just going to go over the lines that I need to in pen, okay. So we'll take this curve here. Okay, and I'm only coming out as far as here this time. I'm going to draw this like that, so that's going to give me the loading shovel. Okay, we know this tangent here, BT, and we did the construction for it. Like this, and it's going to only be heavy from these 2 points. Okay, now, so what else? So okay, so it's going to come like this curve here. Okay, this is and Okay, this bottom section in here. Alright, and then yeah, so then it's just my wheels. Okay, so I'm just going to go over these. Okay, and I'm going to leave it at that then, just for. Okay, these center wheels here, actually, let's put them in. Okay, and then that's basically our question completed. Okay, so I've used, from that we had to know the principle that from a point P in a curve, if we had the major axis circle, we could go back to the center point and across, and that gave me my minor circle. Okay, we knew this identical portion of the same ellipse, so I took the heights from this section and brought them up. I drew in the parabola with the vertex going, or with the vertex at the side. Okay, and I knew that how to draw in a tangent to my ellipse at a point on the curve. Okay, I hope this helps.